Okay, good evening, everybody.
Good evening, sir.
गुड इवनिंग सर.
Is it visible properly?
बहुत अच्छे से सर.
Okay. So today I am live from the classroom. Okay.
Yes, sir.
So we have to start a new chapter today, and that is Laplace transformation. And I gave you problems for practice in the chapter we have done. So please follow that. Okay. Do the problems. Now, as the word transformation is involved, so Laplace transformation is also, one of the transformation which is very, very important. Like Fourier transformation, like Fourier series you write, what you do is you write one function in form of some other function which has got many benefits. So similarly, Laplace transformation, in Laplace transformation also, what we will do is we will write fx as some f of s. Okay, we will write fx as some f of s, and this writing of x to s, this is your original space and this is your Laplace space. So why we write the function in this space? Because it has got certain advantages. Okay, so one of the very important, so you understood this? If I convert this fx into some fs, this will be called transformation, and this will be done by using a particular definition. What is that definition? Fs is equal to integral 0 to infinity, and let me write this as f of t, okay, and e to the power minus st f of t and dt. So you can see कि अगर मैं t में limits लगा दूंगा, if I will apply the limits in t, so t will be gone from this expression. What will be left out is s. So this will be converted into some function of capital Fs. So please be conscious. पहले मैंने small f use किया है जो कि एक टाइप के फंक्शन के लिए है, and then I have used capital F because the nature of the function will completely change. So that's why two different notations, because they are two different functions, right? So because they are two different functions, I am using two different notations. So this will be known as Laplace transformation. So जिसका भी Laplace transformation मुझे निकालना है, उस फंक्शन को मैं यहाँ पुट करूंगा, इस तरीके से इंटीग्रेट करूंगा. S इज अ पैरामीटर, t में लिमिट रखी जाएगी तो सारा फंक्शन जो है वो s में कन्वर्ट हो जाएगा, and this will be called Laplace transformation. Immediate two benefits are solution of differential equations, solutions of differential equation, and solution of integrals. Solution of integrals. So जब मैं ट्रांसफॉर्मेशन की बात करूंगा तो मैं ये क्लेम करूंगा कि Fourier transformation, Laplace transformation and Fourier series, this will result you in questions. I cannot claim that alone Laplace transformation will give you some question. No, I can't claim that. But I can claim that if I read all these three transformations, I am going to get questions in your exam. So sometimes two, sometimes even three. but at least one. Okay. Two important applications are, so can you hear me, everybody?
Yes, sir.
Yes, sir.
Okay. So two important applications are,
Yes, sir.
first,
सर
yeah, हाँ
सर इसके पहले वाला जो चैप्टर था वो खत्म हो गया सर?
हाँ, वो खत्म हो गया। उसमें मैंने तुम्हें सारी टेक्निक्स करा दी। मैंने एक आपको क्वेश्चंस का वो भेजा था, सेट आंसर्स के साथ ग्रुप में भेजा था, वो आप सभी लोग करके वापस भेजो, और अगर कोई डाउट होगा तो हम लोग डिस्कस कर लेंगे, ठीक है?
ओके सर.
ओके।
सर वो जो बुक का जो इमेज है उसको बात कर रहे हैं.
नो नो नो, जस्ट अ सेकेंड. ओके, सो even some of the physical things, they are Laplace transformation of each other. Like you have, you know, Z is the partition function, right? In statistical mechanics, and omega is number of states, right? Number of ways in which the system can be written, or number of ways in which the system will go. So they are related with one each other by Laplace transformation. So most of the time जो Laplace transformation है, ये एक mathematical tool है, और especially 0 to infinity वाले limits के लिए, जैसे कि cylindrical systems हो गए, या फिर spherical polar system हो गए, spherical polar. So ऐसे systems को solve करने के लिए, where the right hand side is not a well behaved function, जैसे most of the time you solve a differential equation when your right hand side is some simple function like sin x, cos x, e to the power x, algebraic functions. But if the right hand side is your not a well behaved function, like delta function is there, unit step function is there, barrier function is there, then there is no technique in normal ordinary differential equation methods to handle that. So we can handle them if the boundary conditions are given at 0 to infinity or something like that. We can handle them using the Laplace transformation. Okay, so these are some benefits. अभी तक जो questions आपके एग्जाम में आते हैं, they are mainly of this nature, that if this is the function, what is the Laplace transformation? Or sometimes they have asked to calculate an integral. तो आपको वो बताएंगे नहीं कि you have to do it using Laplace transformation. Please understand, as soon as you see this e to the power minus something, so this s may not be written. Suppose here 5 is written. So what is this 5? This is s, okay? This
Yes, sir.
is s. So please remember, sometimes you can calculate the integrals also, the differentials also using the Laplace transformation, but the initial focus will be on just the calculation of the Laplace transformation for a given function. That will be our primary focus. So let us start calculating the Laplace transformation, okay, for some functions. Like suppose the first function that I take is ft is equal to 1. Suppose I want to calculate the Laplace transformation of 1. So what will happen? The fs will be equal to 0 to infinity e to the power minus st into 1 into dt, which is equal to e to the power minus st by minus s, 0 to infinity. Okay. Now
Yes, sir.
minus 1 by s e to the power minus s infinity minus e to the power s 0. This is 1 by s only when s is positive, because if s becomes negative, this limit will blow. So that's why we will put this, that Laplace of 1 is 1 by s only when s is greater than 0. Is that okay? Yes.
Yes, sir.
Then
Yes, sir.
this will open the window to calculate many other Laplace transformations, simple transformations, जिसको बाद में तो हमें याद हो जाता है, तो हम उनको सिर्फ यूज करने वाले हैं. Second one is e to the power. So your ft is e to the power at. Okay. Now fs will be equal to integral 0 to infinity e to the power minus st e to the power at into dt, which is integral 0 to infinity e to the power minus s, okay, minus s minus at and dt. Now this will become e to the power minus s minus at over minus s minus a 0 to infinity. This will become minus 1 upon s minus a into e to the power minus s minus a infinity minus e to the power minus s minus a into 0. Okay. Yes.
Yes, sir.
So this will be only 0 when s is greater than a. Please understand this. This will be only 0 when, because if this is positive, then only this limit will be 0, otherwise it will blow, and this will become 1. So it will become e to the power at का Laplace हो जाएगा 1 upon s minus a. Okay.
Yes, sir.
और इसके बाद पहला हमने लिख लिया कांस्टेंट. अब देखो इसमें a अगर 0 हो जाए तो ये तो 1 ही हो जाएगा ना. तो यहाँ देखो a 0 करो तो 1 by s हो जाएगा, तो इससे ये वाला डिराइव कर सकते हैं. यस और नो.
Yes, sir.
अब मान लो थर्ड है कि मुझे लिखना पड़ जाए एफ टी इज इक्वल टू साइन ऑफ ए टी. ध्यान से देखना इसका लैप्लास. तो मैं लिख लूंगा एफ टी इज इक्वल टू 1 बाई 2 आयोटा e to the power iat minus e to the power minus iat. Yes or no?
Yes, sir.
Correct. So now Laplace of f of t is equal to. So now this is constant. Please understand. Laplace of this. Now we know e to the power at is 1 upon s minus a. So I will write 1 upon s minus ia. जो नहीं समझ पाएगा वो बताएगा. Minus 1 upon s plus ia. I have just used this e to the power at. Okay. And this will become 1 by 2 iota s plus ia minus s plus ia over s squared plus a squared, and this will cancel and this will cancel, and uh, this will cancel.
वो IA हो जाएगा.
This will cancel, and 2 will also cancel. So it will become a by s square plus
A upon x square a square.
okay.
Yes, sir. सर मैं इसको इमेजिनरी मान के भी कर सकता था ना, इमेजिनरी ऑफ e to the power i80.
राइट, बिल्कुल
यस सर.
मैंने डायरेक्ट ही फॉर्मूला लगा दिया, आप इमेजिनरी मान के भी कर सकते हो. मैथ्स में एवरीथिंग इज अलाउड बट इट शुड बी करेक्ट.
यस सर.
नाउ सपोज थर्ड हो गया. फोर्थ वन इज सपोज we have ft is equal to cos of 80. तो इसका लैप्लास क्या होगा? fs. so this time let me write real of, इस बार वैसे कर देता हूं, 0 to infinity e to the power minus st e to the power iat and dt. e to the power iat का रियल पार्ट क्या हो जाएगा? cos 80. okay,
यस सर.
right? so this will become the real of integral 0 to infinity e to the power minus s minus ia t and dt. So this will become real of e to the power minus s minus ia over minus s minus ia t 0 to infinity. Correct? So this will become real of minus 1 upon s minus a into, यहाँ ध्यान से देखना, e to the power minus s minus ia infinity minus 1. Now this will become 0 because s is greater than 0. ध्यान से देखना, this is e to the power, ये मैं अलग से समझा रहा हूं, this is e to the power minus s infinity into e to the power ia infinity. I think few days back somebody asked this also in the group. So how come this is becoming 0? This has nothing to do with making the function 0, because this is sine and cos, and sine and cos of even large numbers will fall between minus 1 and 1. So it is this term which is making it 0 only when s is positive. So be very, very careful about this. So it will become real of 1 over s minus ia. We have to take real part. So just write s plus ia and s plus ia. Okay. So you have to take real part. So it will become s over s square plus a square. Right?
यस सर.
Please see it carefully. कोई doubt है तो पूछो.
ये स्टेप फिर से बताओ, ये कैसे लिखा हमने?
कौन सा?
ये अभी जो लिखा है ना, उसके पहले का, मतलब यहाँ हमने देखा कि कौन सा टर्म 0 उसके बाद जो लिखा है वो.
ये तो 0 हो गया, ये 1 हो
नहीं
गया.
नहीं सर, रियल पार्ट इनटू 1 अपॉन s माइनस ia इनटू s प्लस ia.
Conjugate.
हाँ ये वाला.
Conjugate. This is called conjugate. We don't want imaginary part in the denominator, so we multiply it by, suppose here it was s minus ia, so I have multiplied it by s plus ia. Okay, off your mic please.
इसके भी सर जो माइनस साइन है बाहर, रियल पार्ट माइनस 1 अपॉन एस माइनस आई ए माइनस साइन, ये कहाँ पे गया सर लास्ट में?
ये माइनस इसके साथ जाके खत्म हो गया.
अच्छा, इससे पहले तो लिखा था शायद आपने.
Hmm?
Sir,
Hmm.
in the numerator, s plus I is there, no, sir? IA, what happened, sir? Denominator part I understood in the last case.
Mm-hmm.
Denominator, numerator I did. Sir. IA, what happened? S plus IA is there. No?
Real of
Oh, okay, okay. Now understood, sir. Okay. Only I have to take the real part only.
real of a plus iota b is equal to a if a and b are element of real number set, right? Is this okay?
Sir.
This step is okay then? Minus and minus. Who was asking? Is this clear? Okay. Off your mic, please. Whenever you ask, immediately off it. You can ask again by just unmuting it. चलो यहाँ तक समझ आ गया सारे स्टेप्स?
Yes, sir.
तो मैंने एक आपको दूसरी तरीके से बता दिया, एक में पूरी तरीके से ये रख दिया था, और मैं चाहूं तो ये दोनों भी ना करूं. There is another way also that I will not go for this. So what I will do, I will write fs is equal to integral 0 to infinity e to the power minus st and cos at and dt, right? So this will become e to the power minus st by s square plus a square. So e to the power ax, a square plus b square,
S cos 80 minus
a
S-
cos
A
80
cos 80
minus b.
A cos B
सर वो
sin
प्लस हो जाएगा सर एक्चुअली.
No, no.
सर cos होता है तो प्लस.
sir B sin BT.
A cos 80 just a second, integral 0 to infinity e to the power ax sin bx dx is e to the power ax over a square plus x square a sin bx minus b cos bx. Okay, so this will become a cos bx plus b
Is
B sin B.
sin bx. ये लिख के and put it 0 to infinity limit and you will get the answer. Okay, so upper limit will be gone, lower limit is 0, so it will become, this will be gone, so lower limit will become s by s square plus a square. Okay, you can follow this method also. Is that okay?
yes, sir.
So this is the direct integration by using the formula. This also we can follow, right? So we have done till now cos also. There are other integrals जो करने पड़ेंगे लैप्लास निकालने के लिए. Okay, now suppose I want Laplace of t to the power n. Okay, suppose I want Laplace of t to the power n, then what will happen?
1 upon s to the power n plus 1
So
into gamma n.
it will be fs is equal to 0 to infinity e to the power minus st, t to the power n, e to the power minus st, t to the power n, and dt. Okay? This will be the, and what do you know about integral 0 to infinity x to the power n e to the power minus alpha x dx? It is gamma n plus
n
1
plus 1.
over alpha n plus 1. This is gamma integral that you have to use. Okay? So now apply this. This will become gamma n plus 1 over alpha is s n plus 1. So this is the Laplace of t to the power n that will be used very much.
n factorial by s to the power.
And sorry,
ठीक है सर.
okay, perfect. So these are the basic Laplace transformations that we have done. And inverse of the Laplace will be written using the direct Laplace. So because Fourier transformation की तरह यहाँ पे हम फॉर्मूले से नहीं लिखेंगे. जैसे फॉर एग्जाम्पल जब मैं कहूंगा 1/s का इनवर्स फुरियर क्या होता है तो आप कहोगे 1. जब मैं कहूंगा 1/s माइनस a का इनवर्स फुरियर क्या होगा, you will say
e to the power 80.
80. I will say 1 over s n plus 1 का लेप्लास क्या होता है.
e to the power n upon gamma n plus 1.
So अभी देखो आपने निकाला. So that will become t to the power n. So here it should be gamma n plus 1 also. So if you want to calculate, so suppose for example, if I say that what is inverse Laplace of 1/s square, then what you will say? So please see this. The Laplace of t to the power, suppose t लिखूं, so you will get 1/s square.
Yes, sir.
So suppose I calculate Laplace of t, what I will get? It is t to the power 1. So it will become gamma 1 plus 1 by s to the power 1 plus 1. So that will be 1/s square. Yes or no?
Yes, sir.
So 1/s square ka it will become t. And suppose it is 1/s cube. Then, so you have Laplace of t to the power n is equal to gamma n plus 1 by s to the power n plus 1. Okay? So if it is s cube, so what it will be? It will be 2 here, right? So it will be 2 here. So if somebody asks you that inverse Laplace of 1/s cube, so what you will say? Is it t square?
T square by gamma 3.
So you will say t square by 2. Okay?
Yes, sir.
So it will become t square over 2. So please understand this carefully, because many times it will be required from us to write the inverse Laplace. So by seeing the Laplace, we can always write inverse Laplace. Laplace देख के हम आराम से inverse Laplace लिख सकते हैं. देखो समझ आ रहा है सबको? Yes.
Yes,
So
sir.
here gamma 2 plus 1, what happens? So it will
So
become 1. No?
right now, gamma 2 plus 1 is what? Gamma 3, which is equal to 2 factorial, which is equal to 2.
Oh, gamma means factorial.
Oh, gamma n plus 1 is, don't say gamma means factorial. If n is number, n plus 1 is also number, then it is n factorial, okay? Okay?
Ah, sir. Okay, sir.
But if it is gamma half, then it is under root pi, right? And if it is gamma 3 by 2, then it is half root gamma, half root pi. If it is gamma 5 by 2, then 3 by 2 into half into root pi. You getting it?
Ah, sir.
These are the things that you have already studied. But if it is not clear, you should clear it. Very, very important. Now, जब एक बार हम कुछ लैप्लास सीख जाते हैं तो हमारे पास बहुत सारे लैप्लास लिखने की कैपेबिलिटी डेवलप हो जाती है बिकॉज ऑफ द प्रॉपर्टीज. बिल्कुल सिमिलर है फूरियर ट्रांसफॉर्मेशन के साथ. जैसे फूरियर ट्रांसफॉर्मेशन में
अच्छा नहीं बस
अरे माइक ऑफ रखो भाई. इसका माइक ऑन है. सो properties are very important because using the properties we can write so many difficult Laplace transformation very, very easily. So first property is shifting property. Shifting property. The first property is shifting property. Okay. So ध्यान से सुनना. Suppose ft का Laplace fs है. ft and fs form Laplace transformation pairs. What is the meaning of this symbol?
It's a both way transformation.
ft का Laplace fs है. fs का inverse Laplace ft है. Okay. Then e to the power at ft का Laplace f of s minus a हो जाएगा. ये बड़ा ही important. Example, मान लो cos of at का Laplace है s by s square plus a square. Correct? तो e to the power bt cos at का Laplace हो जाएगा s minus b upon s minus b का whole square plus a square. This is called shifting property. So if your function is multiplied by e to the power at, then the Laplace will be f of s minus a. Is that clear?
Yes, sir.
And another example you can take. दूसरा एग्जाम्पल ले सकते हो. अगर साइन ऑफ at का Laplace a by s square plus a square है तो e to the power bt sin at का Laplace a by s माइनस बी का होल स्क्वायर प्लस ए स्क्वायर हो जाएगा. Okay,
Yes, sir.
Yes, sir.
so this is known as one more. Let us do one more. If ft is t cube, so what is the Laplace of t cube? 2 by s square. Then what is Laplace of e to the power 2t
T
t cube?
ये T to the power 4 होगा ना?
Sorry, 3 है ना?
Yes, sir.
Sorry. So n plus 1. So it will be 6. No?
6 by S to the power 4. Yes, sir.
6 by s to the power 4. Then e to the power 2t 3t cube will be 6 by s minus 2 to the power 4. Understand this, everybody. Okay.
Yes, sir.
Everybody is understanding? किसी को कोई डाउट है तो पूछ लो. So I have used shifting property. So किसी के साथ भी अगर 80 मल्टीप्लाइड है तो तुम शिफ्टिंग के हेल्प से लिख सकते हो. और ये ध्यान रखना, इनवर्स लिखते समय बहुत ही ज्यादा केयरफुल रहना होगा. अब मान लो यहाँ लिखा हुआ है कि 1 अपॉन s माइनस 2 टू द पावर 4 का इनवर्स लैप्लास लिखो. समझ रहे हो? सपोज दिस इज योर क्वेश्चन ऑफ इनवर्स लैप्लास. तो यू विल सी कि भाई ये 1 अपॉन s टू द पावर 4 रहा होगा. It would have been 1 over s to the power 4 and it would have been shifted by 2. Can you see that? ऐसे आपको चलना होगा. तो first of all you will write for 1 by s to the power 4 in first step. So you will see that when it is t to the power n, then the Laplace is given by gamma n plus 1 upon s to the power n plus 1. So that means when it is 1 upon s to the power 4, it will be t to the power 3 by 6. Yes or no?
Yes, sir.
Yes, sir.
So that means if you calculate Laplace of this, you will get this, right? If you calculate Laplace of t to the power 3 by 6, you will get 1 upon s to the power 4. Is it true?
Yes, sir.
Right?
Yes, sir.
So 1 upon s to the power 4 will give you t to the power 3 by 6, and then comes the shifting. When it will be shifted by 2, then you will do nothing, just you will multiply it by e to the power 2t because of shifting. So your question is answered that if it is 6 over s to the power 2, 4, then it will be t cube e to the power 2t. So this way you can write always the inverse Laplace of the functions. So inverse बहुत ही ज़्यादा important है समझने वाला. We all should understand how to get the inverse Laplace. Any doubt? So let us calculate. This is clear now?
Yes, sir.
Sir,
Hmm.
sir, if there is some complicated type function,
Hmm.
then how we proceed, like 1 by x cube plus a cube, or
So this is not a good question, because just you have started doing some basic Laplace. So can you ask at the starting of any topic that how to do the complicated problems which will be taught in the last class? Can we ask like that? And how I will answer? What I should say? That okay, I will be using integral, derivatives, and shifting, first shifting, second shifting, unit step functions, barrier functions, all I will use to calculate the complicated functions inverse Laplace. ठीक है? Sort on. So that could be a possible answer. So that's why you will have to learn step by step. First of all, focus on what I am doing right now. These small things will build up your chapter, and then you will be able to do the complicated problems. They will not come from the isolation, but they will come from these small problems. So let me give you a problem that is 3s minus 137 over s square plus 2s plus 401, and I want inverse Laplace of this. Okay, this is the problem. Inverse of this. So please understand this how I will approach. What will be my approach? I am seeing here s square plus 2s. You know that this you can't bring. Constants you can subtract and add. That is not a problem. So if it is a square plus 2ab, so what is a and b? A is s and b is 1, right? In 2ab. So I can write, समझ रहे हो क्या बोल रहा हूँ?
हाँ सर, स्क्वायर कंप्लीट कर रहे हैं आप.
तो जब s स्क्वायर को मैनेज करने की कोशिश करोगे तो यू कैन ओनली राइट s plus 1 square because it will give s square plus 2s plus 1, because this you can't bring. Constant you can manage. So that's why I will write, can you see this? S plus 1 whole square is s square plus 2s plus 1. So I will write this as s plus 1 whole square, and this 1 is already taken care, and this as 400. Yeah. Now you can see that it is s square plus this, and some shifting must have happened. Shifting of -1. इस आइडिया के साथ आप आगे बढ़ोगे कि it would have been something like s square plus 20 square, right? And if it was like this, then it would become s by s square plus 20 square, right? And 3 can be just multiplied like this, no problem. 3 can be multiplied, and what will remain? So let me write it from here. So it will become 3 times s by s plus 1 whole square plus 20 square. So I am getting 3s, and by shifting I will write here plus 1. So I am getting 3 here.
Yes sir.
3 extra, right?
Yes sir.
Yes.
So I will write minus 140 upon s plus 1 whole square plus 20 square. See, everything should be equal to this. Is it coming?
Yes sir. Yes sir.
And then I will write 3 into s plus 1 over s plus 1 होल स्क्वायर प्लस 20 स्क्वायर माइनस, यहाँ देखो जरा, यहाँ 20 ऊपर आना चाहिए, तो आई विल राइट 140/20 इंटू 20 s plus 1 whole square plus 20 square. And please understand, this is very simple now. So this will become, the inverse Laplace will become, right, for this, s by s square plus 20 square. This is sine or cos?
cos sir.
So it will become
To the power
cos
minus
of 20t, right? Cos of 20t will give you s by s square plus 20 square. But plus 1 is indicating for the shifting
e to the power minus t.
e to the power minus t. Similarly here, minus 7, and this is just sine, so it will become e to the power minus t sine of 20t. This is the answer. This is the inverse Laplace I was talking about. Yes?
Yes, sir.
तो किसी को कोई डाउट है तो पूछ लो. So this should be your approach. Even this is like a complicated problem because this is not direct. You have to guess कि shifting हो रही होगी, उस हिसाब से आपको manage करना है. So this is also a good question. And reference book for this chapter is Crazy. So if you have any issue, you can refer to Crazy. Okay. Yeah, clear है भाई?
Yes, sir.
किसी को कोई डाउट? ओके. सो इस तरीके से हम लोग बहुत सारे क्वेश्चंस का इनवर्स लैप्लास निकालने वाले हैं धीरे धीरे करके. एंड बहुत सारे क्वेश्चंस की प्रैक्टिस करने वाले हैं. बट अभी आज आप बस इतना करना कि द बेसिक लैप्लास ट्रांसफॉर्मेशन like 1 sin 80 cos 80 t to the power n, all that we should know. वो अगर एक बार पता चल गया, then we can manage with all the properties and this shiftings and all. So अभी तो मैंने first shifting पढ़ाई है. There will be second shifting also, and there will be, you know, many other Laplace transformation of other functions also. For example, if I take a function like this delta function x minus a, and I want Laplace of this, so I will write, right? And if this a lies between 0 to infinity, then what will be the
E to the
Laplace?
power minus 80. So minus SA. Yes, yes.
So this will be the Laplace of the delta function. This is why we use Laplace transformation so much to solve the differential equations. So इस तरीके की बहुत सारी चीजें हम लोग करने वाले हैं. Laplace transformation of a delta function x minus a is e to the power minus s a. करेक्ट है भाई?
Yes, sir.
बट ये बीच में होना चाहिए, अदरवाइज आंसर 0 आ जाएगा. ओके. अब
Yes, sir.
सपोज यहां e टू द पावर bx मल्टीप्लाई हो जाए तो क्या होगा? शिफ्टिंग.
s plus b.
तो e टू द पावर माइनस s माइनस b into a. So this will become the Laplace of after shifting. So इस तरीके से जो बेसिक सीखते जा रहे हो उसकी इंपॉर्टेंस को समझो. Being very very simple, They are very very powerful. Even though they are very simple, yet they are very very powerful. तो उसके power को आपको समझना है, जो छोटी छोटी properties आप सीख रहे हो. Can you apply those properties in any case? If yes, you are done. So this was today's class.
Sir,
हाँ.